everyone, I'm Alex, the account manager of Moldex 3D EMEA team. So first of all, I would like to thank you for joining this webinar today. And today I'm going to have a presentation about improving structural performance of fiber reinforced plastic parts. So this topic is quite heated up in recent years, especially for customers who are interested how to fill the gap between structure simulation and the reality by having a consideration of molding process, how this process would affect the strength of your product. So make story short, let's take a look about the outline today. In the beginning, I would like to quickly introduce why Moldex 3D. So the theory behind the software and how accurate it could be in terms of a prediction of fiber orientation. And second, I would introduce what Moldex 3D could output for further structural analysis. The last but not the least, I will also share 2 real case studies from our customers who joined the Global Innovation Talent Contest last year, which perfectly showed how they use Moldex 3D as a basis to further perform the structural analysis in order to improve their product. So start from the beginning. I think it is quite well known that fiber reinforced plastic parts has widely acted as a major material for lots of plastic parts in different industries. So because it has the advantages of high strength to weight ratio, high toughness to anti-corrosion, and high creep resistance. So however, fiber reinforced plastics has versatile mechanical characteristics due to different fibers, matrix, and the manufacturing process. As the picture has been shown here, the fiber strength could be different from short fiber to long fiber, even matte or fabric type. And the process will also be different from traditional injection molding to compression molding, such as SMC and GMT and even RTM. And above mentioned process can also be simulated in Moldex 3D. And because of the difference of fiber orientation and the length, their deformation, fracture, and ultimate strength owing to external loads are hard to predict, but very crucial for all the CA engineer.